Hey guys, I'm Mr. C. Welcome to our class on circles. And I'm just calling it circles. I'm not calling it geometry. I'm not calling it algebra because we're doing both. We're going to talk about the geometry of circles and the algebra circles. So yes, we are covering content that you will see in two different classes. But the truth is, both of these ways of representing circles will be represented on the MCAS. So we want you guys to be ready for it. So anyway, this was your warm-up. We only gave you 3 questions today. The first question was really familiarizing yourself, or just, I know that you guys experience this in geometry class, the majority of you. Just what the heck are we talking about with some of these circle terms? It's just some of the stuff, circle, right? A circle can just be identified by the center point. So you actually just call that, circle E. The radius, I guess we get a couple examples here. But segment EF could be a radius. I guess we could also say segment EG would be a radius. More often when we're asked to solve problems, we're asked to use the length of the radius, but I'm just kind of drawing your attention to what these things actually mean. A diameter, well, FG is the diameter, which many of you are familiar with, right? It's basically 2 radiuses. And then the chord. Now, a chord is basically any segment that the endpoints are on the circle. So actually, a diameter is, in fact, a chord. So you get a couple examples here. Segment HI is a chord, but also you could say segment FG is also a chord. So it's a diameter, but it's still a chord. Tangent is the line that just intersects the circle at one point. So we could say that line JK is a tangent. And then secant is a line that intersects the circle at 2 points. So you could say that LM is the secant. I guess we're talking about the lines of these. So I'll put the arrows on either side to show it's a line. Anyway, this is just a review of just general circle vocabulary. So you guys won't be thinking, what the heck am I talking about? Some of these terms I may not even mention today, but I just wanted to take an opportunity to review circle vocabulary many of you learned about in geometry class. Okay, next 2 problems, area and circumference problems. So you guys got your circle formulas that many of you are very, very familiar, right? So you've got the, I guess in this case, we're looking for the area, right? So we're going to talk about the area formula, right? Which is just simply pi r squared, right? Now, I didn't do this by accident. I gave you that diameter to see if I'd catch it. Right, so if the diameter is 5 centimeters, right, the radius is half that, so the radius is only going to be 2.5 centimeters, right? And I'm bringing this up because this is something that will throw you off on MCAS questions. Very often, they'll give you the diameter instead of the radius to see if you're just blindly plugging in numbers or if you know what you're doing. So here we go, the area, basically one of my favorite things you guys have learned over the past 2 weeks together. I love trading numbers for letters, right? Here we go. I'd much rather deal with 2.5, even if it's a nasty decimal, than dealing with R. So now we're going to continue to order of operations, you guys. This is where you could go wrong. If you guys are multiplying before exponents, you're going to go wrong. If you were just doing order of operations appropriately, you won't. Right, pi times 6.25 is, I believe, what that is. You know what, though? I'll check it on my calculator, right? Just to double check, make sure I'm not giving you guys false information. Yep, 6.25 was right. Now, the truth is, you guys, excuse me, that you could actually lead this as 6.25 pi, and of course, you'd have to say cm squared, right? If you want a decimal approximation, you'd have to multiply. You could use 3.14 as pi if you would like, right? If you wanted like a whole number or I guess a number decimal approximation. Excuse me, you guys. Here's that glass of water. I think it went down the wrong pipe. Okay, we got 6.25 times 3.14. Yeah, so you could say the area here is, I guess, 19.6 if we wanted to go to 1 decimal place. All right, so let's check out that next problem in the warm-up, the circumference of a circle with a radius of 4.5 centimeters. Okay, so in this case, what we're doing is we are using the circumference formula. Now, there's 2 of them that you could use. You could either use circumference is pi times the diameter, or circumference is pi times the radius. Oh, excuse me, 2 times the radius. Right? Also could be called 2 pi r. Okay, so now we got our radius, right? Our radius is 4.5. So basically all this is, yep, trading numbers for letters. Pi times 4.5, right? Basically circumference is 9 pi, right? If you wanted a decimal approximation, sure, go crazy, right? Multiply that by 3.14. I'll type that in my calculator to see what I got. Let's see. And you got 28.3 centimeters, right? And remember, it's not centimeters squared because we are talking a length, or circumference is a length around the circle. We're not talking about the area in the circle. Anyway, those are the basics, right? Circle vocabulary, and then area and circumference, right? Now that we've reviewed those things that many of you guys have learned, you know, in middle school, now we're going to get into kind of the nitty gritty. Now we're going to take it to the next level. Now we're going to get to the more challenging place. Now, next slide, we talk about the circle formulas, right? There they are. I basically took this straight out of the MCAS, right? This is actually from your formula sheet. And I know that you guys know those formulas, right? And the fact is, even if you don't, well, hey, they're on the MCAS formula sheet, so there they are. You guys know circumference is the distance around the circle, right? The radius, we just showed what that is from the center of the circle to any point on the circle, right? And the area is just, you know, all of the area within the circle, space taken up within the circle, I guess you'd say. Okay, now, typically, or very rarely, I should say, on an MCAS question or any of these standardized tests, so they're just going to ask you to find the area of the circumference, right? Probably not going to give it to you that easy, right? But two things that you may see very often are sectors and arcs. Now, things I want you to keep in mind here is, first of all, a circle has 360 degrees, right? All the way around the circle is 360 degrees, right? And if you remember, the sector is just a fraction of the circle's area, and an arc is just a fraction of the circle's circumference, right? These problems actually be very, very easy for you because the fraction is always going to be over 360 degrees. So I'm going to show you what I'm talking about as we're doing some IXL preview here, right? So these are the IXL assignments that you guys are going to do tonight or tomorrow or whenever you get to it. And yeah, let's do this. So the diameter of a circle is 8 meters, right? And they tell you that. What is the area of the sector? Well, first of all, I'm going to find the area of the whole circle. Now, you don't have to do this. You could actually do everything that I'm about to show you in one equation, right? But just to break it down, I just want to kind of do it step by step here. Now, of course, right, if the diameter is 8, you got to recognize that that radius is just going to be 4 meters. Right, so the area is pi times 4 squared, which is 16 pi. Right? Now, typically with these problems, if you write in terms of pi, you usually will get credit. Usually, your teacher will give you credit. But just because I know you guys, some people are uncomfortable with, you know, irrational numbers, right? So what I'll do is I'll give you a decimal approximation: 16 times 16 times 3.14. Let's just see what we got there. 16. Yeah, and if you guys are thinking, why is Mr. C wasting my time as he's typing stuff into the calculator? I want you to see I'm doing this for real right now with you. I'm not just throwing up an answer key. And if I'm going too slow, hey, skip ahead a little bit, right? So the area of the entire circle, you know, if we're going to estimate it, we'll just say 50.2. I'll just go one decimal place, even though you could do more, meters. Of course, meters squared, right? So if that's the whole circle, right, that's everything, right? But they're not asking you about everything. They're asking you about the shaded area, right, which is bounded by this 144 degree arc, right? So if you remember, okay, so the area of the entire circle is 50.2 meters squared, right? Now, the sector is just a fraction of the circle. What fraction, right? Well, it's 144 over 360. Now, some of you guys are saying, hey, you could reduce that fraction, right? You could. You could reduce the fraction. But the truth is, this technique that I'm showing you is going to work no matter what that fraction is, right? Now, those of you that recognize that you could reduce it, what is that? What is that? Let's see. 12 over 30, 6 over 15, 3 over 5. Check my math, you guys, right? I think that is 3/5, right? And the way that I said that, well, hey, I just kind of kept taking factors out, right? So I started with recognizing, hey, if I divide this by 12, right, I end up with, yeah, what the heck, I'll show you kind of what I'm doing here, a little behind the curtain, right? So I did 12 over 30, right? I'm like, whoa, that still can be reduced, right? So I said, all right, how about if I go, each of those is an even number, 6 over 15, whoa, still can be reduced. Okay, divide both sides by 3. Oh, hey, I'm glad that I brought you guys through this process because that's not 3/5, it's 2/5. Right. All right, so anyway, I just multiply, I guess I'll just do 50 times 2. Or I should say 50.2 times 2. Let's be exact here. Equals 100.4, right? And then what I'll do is I'll take that 100.4 and divide that by 5. And there I got 20, and round to one decimal place, 20.1 meters squared. So anyway, just remember, if you ever have to find the area of a sector, it is just a fraction of the circle. What fraction? Take the degrees, divide by 360, that's your fraction. All right, very, very similar problem. Truth be told, I don't even know if we assigned this IXL, but I wanted to show you how you would do it if they asked you for the length of an arc. So what this question's asking is this arc here. So the radius is 14 inches, right? And they want to know the length of this arc, not in degrees. They want to know the length of that arc in inches, right? So the way I would do that, and again, I know we could probably do this in one step, one equation. What I'm going to do is I'm going to write your formula, right? Circumference formula, right? Because an arc is just a piece of the circumference, right? So so here we go. I'm going to find the total circumference. And circumference, I'm just trading numbers for letters. 2 times pi times 14. Or in other words, 28 pi. Now, I know many of your teachers would be satisfied with that answer. But hey, those of you guys that want a decimal approximation, I'm giving it to you. All I'm going to do is I'm going to multiply 28 by 3.14, which you guys have seen me do a bunch of times. I'm not even going to write it down. 28 times 3.14. There we go. It's I'm going to round to 87.9 inches. Now, of course, I wasn't asking you about, or excuse me, the question is asking about the entire circumference. They're asking you for a fraction of the circumference. What fraction? Oh, 72 over 360, right? Same thing, we're going to multiply that by 87.9, right? Now, some of you guys are saying, hey, that can be reduced. You're right. Actually, I believe this could be reduced to, let's see, let me both of these could be divided by 36, right? 2 over 10, right? I'm going to reduce it further, 1/5, right? Basically, that's just a fifth of the circle. So, so 1/5, or we could just say, oh, I'll multiply it by 1/5 because that's what we're doing, times 87.9. And that's the same as dividing by 5. 87.9 divided by 5 gets you 17.6. Again, I'm rounding to one decimal place here. All right. So again, an arc, excuse me, is just a part of the circumference. So another thing to remember there. Okay. Now, arcs and angles. Okay, so very, very similar topic here. Same theme. How many degrees are in a circle? 360. So if you see a question like this, right, all you got to do is take all these angles together, add them up to 360. Yeah, I'm dealing with an algebra problem, right? But the situation here is that once you get to the algebra, right, the problem is easy. I shouldn't say easy, but oh, sorry, that's 63. My bad there. 79 and x plus 75. All that stuff adds to 360, right? And once you guys get here, you guys are really good at combining like terms, right? What do we got? We got, looks like we have 2x, right, plus all these numbers together. Ken, I'm not proud. I'm using my calculator here. What do we got? We got 59, right, plus 63 plus 79 plus 75, all that stuff, 276, right? Right, I'll subtract 360, right? 360 minus 276. Okay, so 2x equals 84. And just in case you guys are curious, a little review, I just subtracted 276 from both sides. All right, x divided by 2, right? X equals 42. The thing is, they're not asking you 42. They're not asking you what x is. They're asking you angle HGK. H, where are we? HGK. Okay, there we go. There we go. That's the angle they're looking for. So I'm going to take that 42 and I'm going to add it to 59. Again, I picked this problem out because you got to be ready for this kind of stuff on the MCAS, right? You spend your whole math career solving for x, solving for x, solving for x, and they throw you a little bit of a curveball. They're not looking for x. They're looking for the measurement of angle HGK. So I add these two together. I should be using my calculator for this, but I'm doing a little mental math here, and I believe that's 101, 101. I check my math, you guys, but I'm pretty sure that'll be the right answer. Okay, again, the fact that the circle, all the degrees in the circle add up to 360, right? Very useful piece of information there. Okay, so a couple of angles, right? The angles that we just used were called central angles. Again, this is a review from geometry. Some of you guys, I know 9th graders, I guess rising 10th graders, excuse me, haven't taken geometry yet. But hey, here's a little vocab. Central angle, an angle whose vertex is the center of the circle. So this is an example of a central angle. A little tip on this is that if this angle, in this case, is 40 degrees, the arc will also be 40 degrees. It makes a lot of sense, right? Because all the degrees in a circle add up to 180. Excuse me, I said 180. All the degrees in a circle add up to 360, right? All the arcs in a circle add up to 360. So it just makes so much sense that the central angle and the arc would be the same measurement. Not the case with inscribed angles. Now, what's an inscribed angle? Basically, the vertex is on the circle. The vertex is on the circle, and it's kind of two chords, I guess you could say. And a little something to know is that this angle will actually be half of this arc, right? So if we're saying angle S is 49 degrees, you're going to have to multiply by 2, right? And this will be 98 degrees. So just to show you how I came up with that, 49 times 2 equals 98. So inscribed angles, the inscribed angle will end up being half the arc it intercepts. Another way to say it is that the arc will be twice the inscribed angle. Okay, so now for a little IXL preview, right? This problem, what you're asked to do is they give you the length of the inscribed, the central angle. They give you the length of the inscribed angle. And just what you got to remember, right, is that, well, let's say, so this arc here, right, will be 5x minus 84, right? And so what that means is that this here, right, will end up being half of that, right? So now what I would rather do, right, I would rather multiply by 2 than divide, right, because I don't want to deal with fractions, right? So what I'm going to say is that 2 of these inscribed angles, 3x minus 58, right, is going to equal 1 of the central angles, or the intercepted arc, which is 5x minus 84, right? So once you guys set up the equation, I know you guys are very good at this stuff. 6x minus, oh, what do we got there? Is that 116? Check my math, you guys, right? 5x minus 84, right? So what I'm going to do, my goal, get all the x's on one side. You guys know that I'll subtract by 5x. So x minus 116 equals negative 84. We're almost there. I got to get all my numbers on the other side, so I'm going to add 116. There's a little Algebra 1 review here, right? The first thing you guys did in Algebra 1. And I'm going to use my calculator. Sure, you guys are thinking, Mr. C, aren't you a math teacher? Shouldn't you be able to do this in your head? But hey, I'll tell you what. If they're giving me a calculator to use, I'm using it. Okay, 32, right? Now what thing? Did they ask us for x? No. They're asking us for E, G, F. Right, so they're asking us for this angle here. I'm going to plug it in. 3 times 32 minus 58. What do we got there? Is that 96? I believe it is. 96 minus 58. Okay, again, I'm thinking that should be, I'm thinking it's 38. Right? I did a little mental math there. Basically, I did 96 minus 60 would be 36. I figured, well, it's 2 more. But you know what? I'm not just being happy with that. I'm going to check it with my calculator, double check, make 100% certain that I'm right. 96 minus 58, 38, I was right. Okay, so there we go. Inscribed angles and central angles. Okay, and here's an MCAS problem that you might see, right? Something very similar to this. Okay, so they're saying that GRV, okay, so this triangle is inscribed in the circle, which basically every angle is an inscribed angle. We're telling you that these two segments are congruent. What is the measure of GR? Okay, a lot of geometry here. A lot of geometry, right? First of all, we got to be able to recognize that if this is 20, and that's an inscribed angle, that this is 40. We got to recognize that, right? We also got to recognize that the entire circle adds up to 360, right? So the whole thing adds up to 360. Okay, now a little something here is that chords, and you geometry guys know this, you algebra guys don't, is that if you have chords, right, that means that they intercept congruent arcs, right? Congruent chords intercept congruent arcs. It makes so much sense, right? I mean, if these two chords are the same, right, the arc's probably going to be the same too, and that's true. What's kind of intuitive there is actually true, right? So what I know, let's just say I want to call this x, right? This would also be x. So what I would say is that 2x, x plus x, right? Plus, don't forget about that 40 right there. All of that added together is 360, right? Because all of the arcs in the circle have to add up to 360. So I'll subtract 40 from both sides. 2x equals 320. Divide both sides by 2. X equals 160. Now, if you want to check your work, do they all add up to 360, right? 160 here, 160 here, right? That's 320 plus 40. That's 360, right? 160 is the measure of GR, which is what they're looking for. Okay, that is enough geometry. Now we're getting to the algebra, the equations of the circle, right? Now I have an example here, right? Those of you guys that have taken geometry, especially those of you guys that have taken algebra 2, are very familiar with the equation of a circle, specifically in this standard form that I'm showing you. And hey, just take a look at the formula, right? The thing I want you to really understand here is there's only 2 things that matter when you're dealing with a circle, right? One thing is the center. Where is the circle, right? And the other thing is the radius. How big is the circle? Those are the only 2 things that matter, right? If you keep that in mind, you get yourself a nice, neat formula here. All they're doing is they're taking that 3, plugging it in for A, taking that 4, plugging it in for B, and then the radius. So one thing here is making sure that you square it. So this would actually be 36, right? Or 6 squared. Same thing. I just want you to recognize it. 6 not equals 6 will equal 6 squared, which is 36. Okay. Now, on IXL, we're asking you to do kind of 2 things, right? We're asking you to be able to take a circle, right, and write the equation. Right? The other thing we're going to be asking you to do is take the equation and draw the circle, right? So in this case, remember I told you only 2 things that matter, right? Is the center, right? Center which in this case looks to be 6, 0, right? 6, 0. All right. And then the radius, how big the circle is, it looks like 1, 2, 3. It looks like 3. Okay, so if that is true, all I'm doing here is basically just using my formula, right? So here's my x, or my a, I guess I'll say. This is my b, right? So we've got x minus 6 squared, right? Plus, y minus 0 squared equals 3 squared. Now, if you want to simplify that, just leave this as x minus 6 squared. I mean, some of you guys I know are probably tempted to FOIL it. And who knows, maybe your teacher is asking you to. And if so, of course, FOIL it. But I think vast majority of problems, vast majority of teachers in many cases, just leave it like that and you're good to go. So anyway, that is the equation for that particular circle. Okay, now we're going to do the reverse, right? But remember, the whole thing, only thing that matters, right, is what is the center of the circle and what is the radius, right? Again, the only two things that matter. Sorry about my terrible handwriting there, you guys. But you're looking at this one thing you're going to catch, right? Remember, this is x minus -5, right? So the x coordinate of the center would be -5 here, right? It's minus b, so it would just be 4, right? There's your center, -5, 4. Right? And when students make mistakes, typically they're just mixing up negatives and positives, right? But you want to make sure you don't make that mistake, because you do, you're wrong, right? We don't want you to be wrong. Okay, now another thing I want you to be aware of here, right? R squared is 16, right? So if R squared is 16, right, that's not the radius. The radius is the square root of that, which is 4, right? So what I'm going to do when I draw the circle, radius of 4, right? What I'm going to do is I'm going to go 4 in every direction. 1, 2, 3, 4 over there. 1, 2, 3, 4 there. 1, 2, 3, 4 there. 1, 2, 3, 4 there. And I'm just going to go woo, whoop. And I have effectively graphed that circle. All right. And folks, I think that's it. I think that is it for the day. We've talked about geometry of circles. We've talked about the algebra circles. You guys will have these. You'll see a lot of these similar problems on your IXL assignments. Right? And yeah, I hope you guys enjoyed this video, and we'll look forward to seeing you at our next class.